Hi friends and welcome back to another video. Today it is day 86 on hashtag ASR 99 days data science challenge, and today in this video we are going to look at how the support vector machines algorithm work. So the support vector machine algorithm is a supervised machine learning algorithm which is used for both the classification and our regression type of problems. Now let's take a scenario and in which these are the data points for specific types of cat. So let's name this species A in a cat, and now let's draw these set of points, and these are the points that are a type of species in dogs. So here are our two categories, and now we need to separate these two variables. In order to do that, we will draw a boundary line like this, and then we have to draw two more lines such that they both are on the different sides of our boundary line, and they must lie very closer to the value of the opposite variable. That is, so now let's say I have to draw two lines, and I have to draw one on this A side and one on my B side, and I have to draw that specific line in such a way that it must pass through a particular point which is nearer to its opposite variable. So in this case, this point, or let me draw a new point over here. So now in this case, this red point is very much nearer to my opposite variable B. So in that case, I must draw a parallel line to my boundary line in such a way it passes through this particular red dot. So, and now here is my particular line for my variable A, and for my variable B, this point is very much closer to the opposite variable, and I will draw a parallel line passing through this point. And now the distance between these two lines, let's name it as small b, and the distance between these two lines, let's name it small a, and the total length is a plus b, and we will call this value as our margin. Now you can ask a question. So it is not only possible for us to draw a decision line like this, rather we can draw a decision line like this and take this as the nearest point for our opposite variable and draw two parallel lines like this. And why not we are doing this? We are not performing this second model as our SVM. It's because we have to take a line that has the greater margin value. So in this case, these green lines will give us the greater margin value, not the blue ones, and so we choose our green ones over our blue. And why the name support vector machines? We drew these two lines with the help of our vectors over here, these red and orange points. It is not only that we have to take a single point. So now let's say on this straight line we have multiple orange points, and we can draw a line through them too. And as these are the vectors and they are supporting us to draw this line, and hence we call this as the support vector machines. And now let's try this particular algorithm by performing in our Jupyter notebook. So now let's import the necessary packages. So import pandas as pd, and then from sklearn.datasets, it is a particular module in which we can get some free datasets, and I will import the breast cancer dataset. So load breast cancer, and then from sklearn I will import from sklearn dot model selection I will import my train test split, and finally from sklearn dot svm I will import my svc, that is svc. So here svm is the module in which we have the support vector classifier algorithm, and let's run this. And yeah, now let's load our dataset. In order to load this breast cancer dataset, we must create an instance for it. So let's name it cancer and load breast cancer function, and let's run this out. And here is our particular object for it. And now let's check for the keys. So cancer dot keys, and here we have the data of that particular dataset, and here is our target variable and the data frame and the target names, and DESCR gives the description of our data, and here are the feature names and file name. So now let's access them out. So cancer, and in which we will pass DESCR. Let's print it. Print cancer, and now here we got them. So it has 569 instances of 30 attributes, that is 30 columns, and here are the attributes information, and this is a copy of UCI YAML breast cancer Wisconsin diagnostic datasets, and you can find this dataset in this particular link too, and here are the references. And now let's look at the target names. So cancer, and in which target underscore names, and after using these attributes, our output would be either we have to find whether the particular patient is a malignant or a benign. So let's do it. Firstly, let's create our data frame. So df equals pd dot, we will use our data frame function, and in which we will pass our data key. So cancer of, in which I will pass the data, and then here I got our data, and now I need the column names. So column equals cancer, and I will use the feature names. So feature names, columns, and here we got it. And now let's look at the first 5 rows of our data, and here they are. So particularly this comes out to be our particular variable x, that is the independent variables. And now let's create the dependent variables, and let's name it y, and that is the column target. So cancer, and in which I will pass target. And now let's check for y, and the output is 0 1, where 0 means malignant and 1 means the benign. And now let's train our model. So first let's create an instance for it. So r equals svc function, and now we have to split our data. So xtrain, xtest, and ytrain, ytest, and in which I will use my train test split function, and I will pass in my, so here the variables are my data frame df and y. So instead of x I will pass df and y, where my test size should be equal to 0.2. Firstly let's use with 0.2, and now let's train our data. So r dot fit, I will pass xtrain and ytrain, and now it's time to predict our data. So r dot predict, I will pass the values xtest and Let's run this out, and here are the values. And now it's the time to check for the accuracy score. So r dot score, I will pass x test and y test, and here our accuracy scores comes out to be 0.90, that is 90% accurate. And now let's change the value to 0.33, and it has been decreased to 0.88. And yeah, that's all for today in this video. And in this video we looked at how our support vector machines work. And thanks for watching. Like the video, leave a comment down below, and let's meet on day 87.